Hello everyone and welcome back to Arctic Retro. Today I got a new device that I'm gonna test, and this is the RAD Expansion unit for the Commodore 64. And supposedly with this you can run Doom on the C64. So let's check that out. That's gonna be interesting. I haven't heard that much about this device yet, but I'm in the process of exploring it now, and I'm gonna share my experience with you guys. Besides the RAD expansion unit, I'm also going to install this one. This is the Saruman RAM replacement module for the Commodore 64C, and this I'm going to install in my newly built C64C. So let's actually start with that, and then I'll be back with the RAD expansion unit. I bought this online just to check it out. I have RAM in the machine and I have some spares as well, but yeah, just wanted something new and modern for my newly built Commodore 64C. And if you haven't seen the series of videos I made while building this machine, then I suggest you take a look at those. I bought the Saruman and the 6510 CPU for the C64 at retrolium.co.uk, so you can check out that site if you want to find some parts for your old retro computers. This video is sponsored by PCBWay, and if you need to have produced some PCBs yourself, like I do regularly, then you should visit the PCBWay.com. If you visit PCBWay.com, you can get an instant quote on very good quality PCBs for affordable prices. And if you have advanced needs for PCB manufacturing, then check out their advanced PCB options at PCBWay.com. So this little module replaces the two RAM chips that are in the C64C, and yeah, those two are 464 chips, and they can be hard to find nowadays. So this is a modern replacement for those two, and you just insert this in place of the two RAM chips. So let's do that on the Commodore and see if it works. And to do that, you of course need to open the machine, and that's easy, just 3 screws here in the front of the underside. Now, inserting the Saruman module is not gonna make the machine any faster or give it more memory. It's a simple replacement for 64 kilobytes of RAM. And we need to remove the keyboard and this very large shielding here. Now I still can't stop thinking about how beautiful this motherboard is. It was made by VIC just recently, and he also made a video about making this or designing it, and yeah, we built it at the same time, which was really fun. So I would of course install the Saruman in the video where I built the machine, but it didn't arrive until now, so I couldn't do that. Okay, so I pulled out the two RAM chips, and I have sockets, so this should fit in the socket, but what direction does it go? Well, it has a print here with a notch S that goes in that direction, so I guess that's gonna be easy. Not all the pins are required, obviously, and yeah, just gonna push it gently down there. These pins are a little thick, so it might be a little bit difficult to fit into the socket, but okay, it's in. Before I assemble the machine, I'm just gonna test if it actually is working. Oops. it doesn't work. Okay, that's a bummer. So I took it out and inserted it a couple of times, but still doesn't work. I'm gonna test if it is working in this machine here, which is another C64C that is known to be good. Well, look at that, it actually works in this machine. Well, what could be the reason for that? But at least the Saruman is working, and yeah, no issue with that then. Or could it be that we are so unlucky that something broke on this machine? Let's place back the original RAM chips. Seriously, what is this? The machine has stopped working. I inserted the, the RAM chips and yeah, it has this garbage on the screen. What could have happened here? Oh, okay, yeah. Ooh, that character ROM chip is a kind of loose. I just touched it now by accident and then it started to work. All right, then that's solved. Then we're back into business, hopefully. I really need another chip for that character ROM. The pins of the chip is very short, so yeah, it doesn't sit very well into the socket. Okay, let's check now. Yep, that's working. Alright, so now I have made a modern improvement on this machine, which was the goal. Alright, we're back in business, and now I'm gonna talk a little bit about this, the RAD Expansion unit. Let's take a closer look at the card itself. This one is quite simple. It doesn't have a lot of advanced chips or any logic on its own. This expansion unit is 100% software defined. That means that you have to program it with something else, and that something else is a Raspberry Pi. So you need a Raspberry Pi for this. This is a Raspberry Pi 3B+. The device also supports 3A+ or 02. This was designed by Carsten Dachsbacher. I'm not really sure if I pronounced that correctly, in 2022, so it's fairly new. And you can find this project on his GitHub page right there. I'll link to it in the description of the video if I remember to. One benefit of this is that it supports memory expansion on the C64. That means that it is compatible with the REUs, the 700 series of memory expansions for the Commodore 64, and it's also compatible with some other memory expansion units. So yeah, you can find those details on the GitHub page. You are supposed to power this up from an external power source, even though it can be powered by the C64. It isn't recommended, so I'll try to power it up with an external power supply for the Raspberry Pi. And if you're gonna power it from the C64, then you have to place this jumper there to close this jumper. Then this one goes on top. And then of course you need some software for the Raspberry Pi. If you don't know already, the Raspberry Pi is a complete mini computer that runs Linux and has HDMI output and audio and yeah, USB network, and it runs from a little SD micro card. So we need to find the correct software for this. This isn't sitting very nice, so to avoid something getting shorted here, we need to separate those two cards a little bit. And yeah, I think I have the right thing for that. Yeah. Alright, and then this side up, and you insert it in the cartridge port of the Commodore 64. To find the software that's gonna run this on the Raspberry Pi, I just went to the GitHub page mentioned, and here's all the necessary information that you need about this project, and yeah, everything. If you want to overclock it, if you want to find a 3D case to print for it, known limitations, bugs, if you want to build or change the code yourself. And to find the software, we just go to the latest release and download that. There's one zip file there, and that's the one we're gonna unzip and just copy to a FAT32 formatted SD card. Here's a little SD card, and I have this adapter, and I have a built-in SD card reader on this machine. And I'm just double checking this is FAT32 formatted, and it has 16 gigabytes, so yeah, should fit very well there. And okay, let's see now. Copy the RAD firmware. It's just about copying all the files from the zip file and directly to the root of the memory card, and the memory card already has some other files that are used in different machines and emulators, but yeah, doesn't seem to have affected or overwritten any of those, so this should then work with the Raspberry Pi. Let's test. That goes into there on the back side. Okay, now I'm gonna hook up USB power and HDMI, because this one will produce its own video output via the HDMI, and you can probably see what's going on when it boots and what it does when it's being used. Let's see now what happens. First time I try this. Yeah, there's something on the screen. Found a valid version 4.xx SD card. So I'm not sure if this is gonna have something other than this as output on the screen. Anyway, let's power this off and insert it into the machine. See if anything happens to the Commodore. You're supposed to insert it into the machine and then power up the RAD first. Then wait a little bit, and then you can power on the Commodore. I'm gonna turn on the machine. Yeah, look at that. Nice. It's already configured with 1 megabyte memory expansion. And it even has some cool SID music playing. So here you can change the RAM type, GeoRAM, none, REU, and plus and minus is the size. Okay, you can go up to 16 megabytes. That's cool. Then you exit it by pressing X, and now it booted into Commodore 64 Basic, and yeah, printed out here 16 megabytes of REU RAM. So I really think we need to check if that is in fact working. So I'm gonna try a game that requires additional memory, and that is Sonic the Hedgehog. I have never tested that on a real machine before, only on the emulator, but no, it's actually time to test it. Cool. To find Sonic the Hedgehog, you can go to csdb.dk, or you can just do a simple Google search, and here are download files. I downloaded the D64 variant. Yeah, it's 2 floppy disk images, side A and B. So I'm just going to place those onto the Raspberry Pi 1541. The Pi 1541 is a Raspberry Pi based floppy emulator. So yeah, for this setup then I need 2 Raspberry Pis, which I have. Yeah, and here's the other one, and yes, only problem, I don't have a power supply. I can probably find something that fits. It's just USB micro. Sonic is on that memory card then, so yeah, This is, as I said, a floppy drive emulator. It uses the regular serial cable as the 1541 floppy drive does. Alright, the Pi is hooked up with power. It's red light, so that means it's powered on. Okay, so now I'm gonna load the file browser 64. You can of course mount the correct floppy disk image directly onto the Pi 1541. Problem is I never remember what buttons to push. So I use this instead. So there's Sonic the Hedgehog. And this, as I said, can't run on a regular C64 without the RAM expansion unit. At least it didn't when it came. I'm not really sure now if that's still the case. Use fast load or compatible load. Let's try fast load. Not really sure if that works with the Pi 1541, but it is pretty compatible with a real 1541 drive. If it doesn't work with the fast load, then I'm gonna try once more without the fast load. I think it takes a while to load even with the fast load because it's quite a large game. It's over 2 sides of a full floppy disk, so it's kind of large game. No, I don't think that worked. This took a very long time and nothing happened, so I'm actually gonna recycle the machine and power it on. Gonna try once more, and now I have mounted the actual floppy disk image directly into the Pi 1541, so I don't need to go through that file browser interface first. Also set it down to 1 megabyte. Compatible this time, and the game. Okay, Sega. It's another thing I found out, that tune in the RAD menu, it wasn't actually a SID, it was a PCM file, a wave file actually. So yeah, with this RAD you can actually play wave files through the Commodore 64. I'm gonna explore that a little bit later. Yeah, seems to be doing its thing, and it takes a while. Okay, so here we got the question if we want to load the full game into the memory expansion immediately. So I'm gonna select yes to that. And that's gonna take a while, I guess. Loading 2 whole floppy disk sides at normal 1541 floppy disk speed takes a few minutes, in fact. So the memory expansion is definitely working. I mean, I'm pretty sure you wouldn't come this far without the memory expansion if you try to run this game on a regular C64. So remember now that this memory, this additional memory, is not chips on the RAD expansion unit. It is in fact memory on the Raspberry Pi that's being used for this. The RAD unit only has a couple of regular 74 logic chips and nothing much than that. So while we wait for Sonic to load, we can actually take a look at some of the details here. And yeah, here is in fact revision 0.1. Yeah, as you can see, it's quite simple. It has some chips, 74 chips, a 573, 2 of those, 274, 257, 1 245, and this one I'm not really sure, it's 3861, never heard about it, and a 74 HTC 30. And that is in fact everything. And yeah, you have the connector and some capacitors and resistors and the 2 buttons. So let's check what is this chip here. It's yeah, 10-bit bus switch, TTL compatible input levels. Okay. So this in fact stopped loading now, so I guess I'll have to swap to the other floppy disk. So there, and then select this side B. Okay, and now let's switch back to start and see if it continues. No, it didn't. No, it just hangs and I couldn't get any response anymore. So just gonna try once more and see image modified, unmount. Maybe 1 meg was too little, so I set it to 16 meg then, and yeah, let's try this now. So now I have set it to 16 megabytes and I'm gonna try to load the full game into the RAM expansion unit again. If it doesn't work this time, then I'm gonna skip this and just play the game. Okay, so now it actually says insert side B and press fire to continue, so I have swapped to side B and pressing fire. And here we can see how it looks on the Raspberry Pi when it is loading data from the disk image. Yes, look at that, it worked! So now the full game is loaded into the RAM expansion, and yeah, we can play all the levels without any loading or any delays. And this is quite cheaper than buying an original REU, which nowadays costs maybe several $100. Yeah, it seems to be running very smoothly. Yeah, I made it through the first level. That's cool. And now, without loading, level 2. Alright, let's check out the thing that you're all waiting for. How do we play Doom on the C64 with this? To do that, you go to another repository on this FRNTC GitHub user, and here you find RAD Doom. RAD Doom is a tech demo for the RAD expansion unit. And in this case, the RAD replaces the CPU and runs Doom on the ARM CPU and uses the Commodore 64 for video output and audio sample playback using the SID. So that's kind of cool. So you can play Doom on your C64 C128. It runs with 50 frames per second rendering. It plays audio with 22 kHz sample playback using the SID. Optionally, you can play game music via MIDI and the Digimax sound output. I'm not really sure what the Digimax sound is, but some of you probably knows. So to run this, you obviously need the RAD expansion and the Raspberry Pi, which we have. So here we're gonna download the release, latest version, and we're gonna place that onto the SD memory card. Then the actual game we have to download elsewhere. Secondly, we need to download the Doom 1 WAD file of the shareware version of Doom from, for example, doomwiki.org, and also copy it into the RAD Doom folder on the SD card. So let's see if we can find that. So here it is, and yeah, download Doom 1 WAD. Okay, so now let's unzip this and copy it to the memory card. Copy that Doom 1 WAD into the RAD Doom folder first. Then just insert the card back into the Raspberry Pi and we should be ready to go. So remember that this will run on the Raspberry Pi on the ARM processor there, but it will output the video and audio via the Commodore 64, and yeah, that will be interesting to see. So we're not gonna load anything from the Pi 1541, just this will run when you power on the machine. Yeah, that seems to have loaded on the Raspberry Pi. Let's check now on the Commodore what's happening there. Exciting. Oh, there's at least some music, but no video output. I'm gonna try and reset. Okay, it was just that the video cable was a little bit not properly inserted. Okay, alright, I think I never heard the music like this on the C64. So, loading Doom. Okay, we can play new game. Can I use the joystick? Nope. But I can use the cursor keys. Keyboard control. I, J, K, L. So it seems like it can only use the keyboard, not the joystick. Yeah, there's some settings there on F1, keyboard F3, mouse. Well, I don't have a mouse. So you can control the dithering of the graphics here. Color mix, WS. Weapons are 1, 2, 3, and the move is at and semicolon. Not really sure how good this will look on the video, but yeah, it looks great. So I figured the correct keys now for playing, and yeah. I did play some Doom back in the day, but I don't know if I remember now how to move around on this first level. So how do they do this? Technically, I'm not sure. I have no idea how this is done. So how do we activate the lock? I mean, is it the Commodore 64 that's playing this game now? No, it's not. It's the Raspberry Pi, but still it's played using the Commodore 64. Oh my god! Okay, I finished first level. Nice. So that was amazing, really awesome. Okay, I think that's enough with playing Doom. The demo seems to work great. I mean, how on earth did they do this? But there's obviously some trickery here that I'm not aware of. Yeah, but really cool anyway to see it working. So there was another thing I was gonna investigate, and that was playing audio samples. Let's take a look at that. So a couple of other things I wanna show you. On the memory card you have a few folders. You have this RAD, and it contains the music that you hear in the menu screen of the RAD, and you can actually replace that. So I'm gonna replace the original music with something I mixed up in Audacity. I downloaded a regular MP3 song, free one, and I resampled it down to mono 15,600 Hertz. Another thing, you have a folder called RAD here, and here you can actually place programs that you can run directly, and I just played a Nuvi player PRG here. I'm gonna test that out later just to check that it can be started from the menu of the RAD. So let's check it out. Yeah. So what you're hearing now is this Commodore 64 playing a really long sample from the memory card via the Raspberry Pi. And we also see now that the program I placed into the program folder is shown, the Nuvi player, and just hit enter to start that program. So it says no valid Nuvi data found, and that's because I didn't place any so-called Nuvi files there. So that's something I'm going to take a look at now. I have downloaded a large zip file with a lot of so-called Nuvi files for playback through the REU, and yeah, so I'm gonna copy some of these. As you can see, these are 16 megabyte large, and yeah, that's the maximum we can place in the REU, or the memory expansion. So I'm just gonna copy a few of those REU files over to the REU folder on the memory card. There's a lot here, and there's also couple of programs, the Nuvi player, a couple of other programs. I'm also gonna copy this program here, Blue REU Crest. I'm not sure what it is. I'm just gonna copy that. And there's also a Nuvi player version 1. Copy those two files into the RAD PRG folder on the memory card. Okay, let's test and see if this works. These Nuvi files are yeah, sort of video files with music and video. So I have never seen those kinds of videos before. I think it was invented by some demo makers. I'm gonna copy a couple of more. Here's some Monkey Island and Minecraft. Okay, now let's run the Nuvi player and check if it can find anything. Okay, no valid Nuvi data found. So I need to figure out how to load those files. And of course we need to set it to 16 meg. So let's see now. I'm gonna run this Blue REU Crest, see what that's about. RAM expansion found, but data check failed. Maybe you forgot to load the demo data into the REU. So maybe we need to do this. Maybe we need to select the file for the REU. So now it's selected, and then I'm gonna run the Nuvi player again. Let's see if this is the way to go. A little bit of missing instructions here. Well, look at that, it actually loaded, so that was the correct way. Okay, so that's a little bit of Monkey Island. Cool. Oops, it crashed. crashed and burned. I'm gonna select Minecraft 2 then, see if that works any better. Okay, so yeah, Minecraft test 2 disco shit. Okay, cool. Alright, so it seems to be a little bit buggy here. Yeah, it plays a while and then it just kills it. Let's try the other Nuvi player, see if there's any difference. The one that came with this RAD expansion. Nope. See this blue REU crest, see if that can play that Minecraft video. No, it made a little noise and then it actually just hangs. Here's another one. Okay, just crashed too. So I'm not really sure why this happens. I know there's some tweaking you can do with regards to the timings and stuff like that on the Raspberry Pi. There are settings files on the memory card, and I might try to figure out if changing some of the settings will help. But yeah, at least we proved that this actually can work. So yeah, it's kind of interesting. Alright, so that was kind of a fun project. This is not a released product or anything like that. This is just a hobby project from the guy and he publishes the things on GitHub. So hopefully there will be some development here and maybe some other cool stuff will arrive to be used with this RAD expansion module. Anyway, that was it for this video and I hope you enjoyed the content, and thanks a lot for watching, and special thank you to my Patreons. See you, bye bye.